Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection of an engineering object into which the front view face, the top view face and the right hand side view face of the solid, they have been appropriately combined into a single 3D isometric projection over here. So now using the information available with us through this 3D isometric projection, we are required to evaluate the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections over here. So in order to evaluate the orthographic projections of the solid, we need to determine the dimensions of the front view face, top view face and the right hand side view face corresponding to the solid. So when the observer is going to look at the solid from the front side, so we observe that the width of the solid happens to be equal to 100 millimeter, while the total height of the object has not been provided to us directly. So here we need to add dimensions corresponding to the height of different elements over here in order to obtain the total height of the object. So here we will see that corresponding to element number 1, which is a horizontal wave carrying a rectangular hole at the base of the horizontal wave. So here we have got the height of the horizontal wave equal to 18 millimeter. So then we have element number 2, which is a vertical wave which is lying at the center of the solid. So here we have got corresponding to this vertical wave, height is equal to 22 millimeter available over here up to the center point from the top surface of this horizontal wave. And then we have got a semicircular top portion corresponding to this vertical wave. And this top semicircular portion of the central wave, it is having radius is equal to 22 millimeter. So this distance is 22, this distance is 22, that makes it 44 plus 18. So we get total height of the solid equal to 62 millimeter. So the front face of the solid will be measuring 100 millimeter width of the solid, 62 millimeter height of the solid. When the observer is going to look at the solid from the top, so we are going to observe that the width of the solid, it is equal to 100 millimeter, while the depth of the solid, it is equal to 44 millimeter. So the top view face of the solid will be measuring 100 millimeter width and 44 millimeter depth of the solid over here. When the observer is going to look at the solid from the right hand side view orientation, so we observe that the depth of the solid, it is equal to 44 millimeter, while the height of the solid, as we have already determined, it is equal to 62 millimeter. So the side view face of the solid will be having dimensions 44 millimeter depth and 62 millimeter height of the solid. Let us proceed to evaluate the construction of orthographic projections of this engineering object. In order to obtain the orthographic projections of this object, so here we have drawn the XY reference line, the X1, Y1 reference line, and we have also obtained a transfer line originating from the intersection of XY reference line and X1, Y1 reference line, and this transfer line, it happens to be inclined at an angle of 45 degree with respect to the XY reference line, and we are going to require this transfer line in order to transfer the distances alongside the depth of the solid from the top view projections into the right hand side view projections over here. So since we are required to obtain the orthographic projections of the solid into the first angle projections, therefore the front view orthographic projections will be obtained above the XY reference line, the top view orthographic projections will be obtained below the XY reference line, and the right hand side view orthographic projections of the solid will be obtained on the left hand side of the front view projections above the XY reference line. So let us proceed to evaluate the dimensions of front view face, top view face and the right hand side view face of the solid. So we know that the front view face of the solid, it is having dimensions 100 mm width and 62 mm height of the solid. So here we have drawn two vertical projector lines into the front view projections such that the distance between these two vertical projector lines, it happens to be equal to 100 millimeter, which is the width of the solid over here. And we have extended these two vertical projector lines appropriately into the top view projections as well, because in the top view projections also we are going to require the width of the solid equal to 100 millimeter. Now we know that the height of the solid happens to be 62 millimeter. So here we have obtained a horizontal projector line at a distance of 62 millimeter from the XY reference line, and we have extended this horizontal projector line appropriately into the right hand side view projections over here, because into the right hand side view projections as well we are going to require height of the solid equal to 62 millimeter over here. Now in order to draw the top view face, we know that width of the solid, it is equal to 100 millimeter, which we have already obtained. Now we know that the depth of the solid, it happens to be equal to 44 millimeter. So now we have to draw two horizontal projector lines into the top view projections such that the distance between these two horizontal projector lines, it happens to be 44 millimeter, which is equal to depth of the solid. And we have appropriately transferred these two horizontal projector lines using this transfer line into the right hand side view projections over here, so that we obtain this depth of the solid equal to 44 millimeter appropriately into the right hand side view projections over here. So this way we have been able to obtain top view face of the solid measuring 100 millimeter by 44 millimeter and the right hand side view face of the solid measuring 44 millimeter by 62 millimeter over here. Now let us evaluate the front view orthographic projections of the solid. Now when the observer is going to look at the solid from the front view orientation, now let us obtain different elements of the solid into the front view alongside the width of the solid over here. So now we know that into this horizontal width we have got two circular holes over here. So the location of the circular hole center we have been provided as 25 millimeter from the right hand side face and 25 millimeter from the left hand side face of the solid. And these two holes, they are having dimension is equal to 10 millimeter diameter of the hole. So here from the right hand side face of the solid, we are going to mark the center point corresponding to this hole number 1 into this horizontal element over here. Now we have measured a distance of 25 millimeter from the right hand side face of the solid and a vertical center projector line we have been able to obtain into the front view projections, and we have extended this center projection line into the top view projections over here. Similarly, from the left hand side face also, we know that the center point of this hole, it is lying at a distance of 25 millimeter from the left hand side face of the solid. So now from the left hand side face of the solid, which is this one, we have marked a distance of 25 millimeter. Another vertical center projector line we have obtained into the front view projections, and we have extended the center projector line into the top view projections as well. Now we know that the diameter of these two holes, it is equal to 10 millimeter. So now we are going to take an offset of 5 millimeter on the left side and 5 millimeter on the right hand side of the center line, so that the projector lines corresponding to this extreme ends of the diameter we are able to obtain into the front view projections over here. So here we have obtained two black vertical projector lines corresponding to the diameter of this hole into this horizontal web over here in the front view projections, and these two vertical black projector lines we have appropriately extended them into the top view projections as well. Similarly, corresponding to the second hole into this horizontal web, once again, since the diameter of this hole is also 10 millimeter, so again from the center line we have taken offset of 5 millimeter on the left side and 5 millimeter on the right hand side, and this diameter of 10 millimeter we have obtained through these two black vertical projector lines into the front view projections, and we have extended these two black vertical projector lines into the top view projections as well. Now we also know that this vertical web, that is our element number 2 over here, which is perpendicular to the front face of the solid, it is having width is equal to 12 millimeter, and this vertical web is available centrally on top of the horizontal web, because we know that this distance is 44 millimeter. Similarly, this distance is also 44 millimeter. So this 12 millimeter means that this web, it is located centrally on top of this horizontal web. So we have taken the center point of this vertical web as 50 millimeter from the right hand side face of the solid over here. So here we have measured a distance of 50 millimeter from the right hand side face of the solid, and again another vertical center line corresponding to the center of symmetry of this vertical web we have obtained into the front view projections over here, and this vertical center projector line, once again it has been appropriately projected into the top view projections over here. So now we also know that this width of this vertical web, it is equal to 12 millimeter. So from this center line, now we need to take an offset of 6 millimeter on the left hand side, and again another offset of 6 millimeter onto the right hand side. So we are going to obtain two vertical projector lines corresponding to the thickness of this vertical web into the front view projections, and we have extended these two vertical projector lines appropriately into the top view projections as well. And next we also know that into this element number 1 we have got a rectangular slot which has been provided at the base of the solid over here. The thickness of the right hand side web of this particular element number 1, it is equal to 12 millimeter. Similarly, the thickness of left hand side web of this particular element number 1, it is also equal to 12 millimeter. So now we are going to mark a distance of 12 millimeter from the right hand side face corresponding to this vertical edge over here. This is a vertical face. So now once we mark this distance of 12 millimeter, so one vertical projector line we have obtained into the front view projections, and we have extended this vertical projector line into the top view projections as well. Similarly, corresponding to this web which is appearing into the left hand side portion of the solid, which is having width is equal to 12 millimeter. So from the left hand side face of the solid, again we have marked a distance of 12 millimeter, and we have obtained a vertical projector line into the front view projections, and we have extended this vertical projector line into the top view projections over here. So all the dimensions corresponding to different elements of the solid alongside the width, they have been appropriately obtained over here. Now let us obtain different elements of the solid corresponding to the height of the solid. So we know that corresponding to this rectangular slot which is appearing at the base of the solid, this height, it is equal to 9 millimeter. So now we are going to mark a distance of 9 millimeter alongside the height from the XY reference line, and we will be obtaining a horizontal projector line into the front view projections, and we have extended this horizontal projector line appropriately into the right hand side view projection view over here. Then we know that the top surface of this element number 1, which is a horizontal web, it is having height is equal to 18 millimeter. So now we are going to take a distance of 18 millimeter height from the XY reference line, and we will be obtaining a horizontal projector line into the front view projections, and we have extended this horizontal projector line into the right hand side view projection view over here. Then we also know that this height, it is equal to 22 millimeter, and this semicircular radius, this is also equal to 22 millimeter. So now from this top surface we know that this radius will also be equal to 22 millimeter. So now from the top surface we are going to measure a distance of 22 millimeter, such that this center point of this bigger hole, which is lying onto this vertical element number 2, can be located appropriately into the front view projections over here. So now, having measured a distance of 22 millimeter from the top surface, a horizontal center line corresponding to this center of this hole over here, it has been obtained into the front view projections, and we have extended this horizontal center line into the right hand side view projections over here. And now we know that this hole which is there in the vertical element number 2, which is required to hold a shaft over here, so it is having diameter is equal to 20 millimeter. So now we need to take an offset of 10 millimeter above this center line and 10 millimeter below this center line, and two black horizontal projector lines which are going to depict this diameter. We can check this end and this end of the diameter. So they will be located over here, and these two horizontal black projector lines we have obtained into the front view projections, and these two black projector lines, they have been appropriately extended into the right hand side view projections also. Now let us darken those surfaces which are visible to the observer from the front view orientation. Now as the observer is going to look at the solid from the front, so this surface will be visible to the observer from the front view orientation. Since this surface happens to be parallel to the vertical plane, so the observer is able to witness the true shape of this U-shaped surface of the horizontal web or the element number 1 over here. And now corresponding to this vertical surface, we observe that up to the center point, so this rectangular projection up to the center point, this is also parallel to the vertical plane. So observer will be able to view the true shape of this vertical web up to the center point over here. So this surface is also true shape, but the surface which is lying above the center line over here, because this is corresponding to a semicircular arc which is available with us at the top portion of this vertical web. So since this is a curved surface which is being projected as an apparent shape in the form of a rectangular shape over here, so this projection which we have obtained above the center line, so this portion, even though it appears as a rectangular projection, but it is corresponding to the circular portion of the semicircular arc over here. So this is the apparent shape projection over here. So now we can conclude that the portion below the center line, so this total portion happens to be true shape, whereas this rectangular portion above the center line will be depicting apparent shape of this element number 2 over here. Next we observe that these two holes, they are not visible to the observer directly from the front view orientation. So corresponding to these two ends of the diameter and corresponding to these two ends of the diameter, so we are going to observe hidden line or the dotted line projections into this horizontal wave in the front view projections over here. So here hidden line projections will be visible to the observer over here. Similarly, into this vertical web as well, corresponding to these two ends of the diameter. One end is this one, another end is this one. So again, this hole is also not visible to the observer from the front view orientation. So we are going to observe hidden line projections corresponding to this circular hole having diameter is equal to 20 millimeter into the element number 2 over here. Now let us proceed to evaluate the top view orthographic projections of the solid. Now as the observer is going to look at the solid from the top, so we observe that these two holes and even this hole, all these three holes, they are located centrally alongside the depth of the solid. So the total depth of the solid happens to be 44 millimeter. So now we need to take a distance of 22 millimeter either from the front face of the solid or from the rear face of the solid. So now we have taken a distance of 22 millimeter from the front face of the solid over here, and now we have obtained a horizontal center projection line into the top view projections, and we have transferred this horizontal center projector line into the right hand side view projections using this transfer line over here. Now we know that this diameter of the hole which is lying onto the horizontal web, it is equal to 10 millimeter. Now corresponding to these two ends of the diameter of the hole, we know that total diameter is 10 millimeter. So now we have to take an offset of 5 millimeter above the center line and an offset of 5 millimeter below the center line. So two black horizontal projector lines depicting 10 millimeter diameter of the hole, which is going to depict these two ends of the diameter of the hole measuring 10 millimeter. So now having obtained these two black horizontal projector lines into the top view projections, now we need to transfer these two black projector lines corresponding to the two holes in element number 1 into the right hand side view projections over here. So this way, using this transfer line, so this dimension of 10 millimeter corresponding to these two hole diameter, so they have been appropriately obtained into the right hand side view projections over here. Another thing we know that corresponding to this diameter which is measuring 20 millimeter over here, which is located centrally alongside the depth of the solid over here. So another set of two horizontal black projector lines have been obtained which are located at an offset distance of 10 millimeter above the center line and 10 millimeter below the center line, so that this diameter, one end will be this one, another end of the diameter will be this one. So this diameter we have to depict into the top view projections over here, and these two black horizontal projector lines corresponding to this bigger hole into the vertical web, that is element number 2, they have also been appropriately transferred into the right hand side view projections using this transfer line over here. Now let us darken the surfaces which are visible to the observer as the observer is going to look at the solid from the top. Now we can check, when the observer is going to look at the solid from the top, this boundary of the solid, it will be visible to the observer over here. So here we have drawn the boundary of the solid which is visible to the observer. So besides this boundary, the observer will be able to witness this vertical web which is our element number 2. So even though this vertical web, it is carrying a semicircular surface at the top of this vertical web, but this semicircular top surface of the vertical web, it will be projected as a rectangular apparent shape projection into the top view projection over here, because the semicircular web, it is not parallel to the horizontal plane. So we are going to obtain a foreshortened apparent shape projection corresponding to the semicircular web appearing as a rectangular projection into the top view projections over here. But another thing we should understand, this top surface of the horizontal web, so half of this top surface is lying onto the right hand side, half of this top surface of this horizontal web, it is lying onto the left hand side portion of the solid. So this horizontal surface, so both of these surfaces, they happen to be parallel to the horizontal plane. So therefore true shape of this surface will be visible over here into the top view projection, and the true shape of this surface will also be visible to the observer into the top view projections over here. So whereas this rectangular projection, it is an apparent shape projection over here. Now we also know that this hole corresponding to these two diameter ends over here, so this hole is not visible to the observer from the top. So observer will be able to view the hidden line projections corresponding to these two ends of the diameter into the top view projections over here. Whereas these two holes which are carried by the horizontal web, they will be visible to the observer as true shape projections over here. So this slot will be parallel to the horizontal plane over here. So we are going to obtain true shape projections corresponding to these two circular holes having diameter is equal to 10 millimeter. And another thing we should observe, here we have got these two vertical surfaces over here. So this vertical surface and this vertical surface, so they are projected as edge view projections into the top view projections as hidden line projections over here, because this surface and this surface, they are not visible to the observer from the top. So we are going to obtain hidden line projections corresponding to these two vertical faces of the rectangular slot which is available with us onto the base of this horizontal web over here. Let us proceed to evaluate the surfaces which will be visible to the observer as the observer is going to look at the solid from the right hand side view orientation. So when the observer is looking at the solid from the right hand side face, so we see that this portion, so all of this portion, it is parallel to the profile plane, this surface as well as this surface. So observer is going to observe true shape projection corresponding to this rectangular surface of horizontal web or the element number 1 over here. So this surface will be projected as true shape projection into the right hand side view projection view over here. Similarly, corresponding to this vertical surface which is again parallel to the profile plane, so observer will be able to view true shape projections of this surface into the right hand side view projections over here. Similarly, since this hole, it is also parallel to the profile plane, so the true shape projection corresponding to this hole having diameter is equal to 20 millimeter, it will be visible to the observer as a true shape projection over here into the right hand side view projections over here. And this surface corresponding to the rectangular slot, so this top surface, it is not visible to the observer from the right hand side view orientation. So this surface will be projected as an edge view projection as a dotted line projection over here into the right hand side view projection. So we are going to obtain a dotted line or a hidden line projection corresponding to this surface into the right hand side view projections over here. And finally, these two holes which are lying onto this horizontal web, so we are going to observe hidden line projections into the right hand side view projections over here corresponding to these two holes which are going to overlap with each other. So these two holes, they will be overlapping into the right hand side view projections over here. So this is the diameter of 10 millimeter which is corresponding to these two interior two black lines over here. So here we have got dotted line or the hidden line projections drawn over here into this horizontal web over here. So this way we have been able to obtain the orthographic front view projections, orthographic top view projections, and the orthographic right hand side view projections corresponding to an engineering object for which the 3D isometric projection depicting the constructional details of the object was available with us. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.